Dear students, in this session we will discuss about types of frequency modulation. In the previous video we have discussed about the bandwidth of the FM signal. See, theoretically bandwidth is infinity and practically its bandwidth is 2n into FM. And bandwidth of the FM signal depends upon the modulation index, that is MF. If modulation index is high, bandwidth is a large number. So, corresponding to a high bandwidth, modulation index will be high. Similarly, when the modulation index is low, the bandwidth will be smaller. So, based on the modulation index, frequency modulation is divided into two. They are narrow band FM and wide band FM signals. First of all, let us see what is narrow band FM signal, that is NBFM. In narrow band FM signal, modulation index is small. That means the number of sidebands will be small, so the bandwidth will be small. When the modulation index is small, then the number of sidebands will be smaller in the case of FM wave. That means the bandwidth will be very low. Figure shows the narrowband FM generation diagram. So it consists of, see, in the case of FM there will be a carrier signal and a modulating signal, and here the modulating signal and carrier signal is applied to a balanced modulator. See, first of all, modulating signal is applied to an integrator, you can see here, and then that signal will be applied to the balanced modulator. Similarly, carrier signal will be first in 90-degree phase shifted by a phase shifter, and then it will be applied to the balanced modulator. So, you know the balanced modulator function, that is, it acts as a product modulator. So, its output will be a double sideband suppressed carrier signal. So, to this double sideband suppressed carrier signal, a carrier signal is directly applied in this manner. So, at this summer, DSB-SC signal will be added to this carrier signal and will produce a narrow band FM signal. See, in the case of FM signal, there will be larger number of sidebands, but since here we are using balanced modulator, it will produce only two sidebands, that is upper and lower sideband. So, to that upper and lower sideband, a summer will add a carrier also, so that you will get two sidebands and only one carrier frequency. That means there will be limited number of frequency components in the spectrum. So it will produce small wavelength, small bandwidth. So thus it produces narrow band FM signal. So let us see, here balanced modulator produces DSB-SC signals, and this is that is sideband terms are produced by the balanced modulator. Then the carrier term is added to the sideband term, and basically narrow band FM is used by the FM mobile communication services because its bandwidth is small. And these mobile communication services include police services, ambulances, taxi cabs, radio controlled appliance repair services, and short range VHF ship to shore services. This uses FM, that is narrowband FM services, narrowband FM, because its bandwidth is smaller, so its range of communication will be small. Okay. Next, the maximum frequency deviation allowed in the case of narrowband FM is 5 to 10 kilohertz. And maximum modulating signal frequency used here will be 3 kilohertz, and modulation index is near to unity, or sometimes it may be higher than unity or higher than unity. So next we will go to wideband FM, that is WBFM. In wideband FM, modulation index will be very large, so the number of sidebands produced will be higher, which in turn increases the bandwidth. And maximum modulation index in the case of wideband FM will be 5 to 2500. That means it is a high value, so it produces large number of sidebands, so bandwidth will increases due to this. Maximum permissible deviation for the wideband FM signals is 75 kilohertz, whereas in the case of narrowband FM it was 15 kilohertz. And the bandwidth of the wideband FM is 15 times higher than that of the narrowband FM. And wideband FM systems are used in entertainment broadcasting, sound accompanying TV transmission, NTSC systems and PAL systems. All are color television systems. So it will be mainly used for high bandwidth applications such as entertainment broadcasting. And figure shows the generation of the W band FM signal. See here, in this case a modulated signal is applied to a narrowband FM modulator so that it will produce a narrowband FM, and for the signal, narrowband FM signal will be given to the frequency multiplier where the frequency is increased. As a result, wideband FM signal will be produced. So, a narrowband frequency modulator is used for the generation of the narrowband FM signal, and narrowband FM signal is applied to the frequency multiplier to increase the frequency deviation to the desired level. As a result, wideband FM signal will be generated. That's all about this classification of the FM signal. Thank you.